Hello everybody, I'm Captain Mam again. We'll start off from where we left on plain sailing. We had talked about a curved line made on the surface of the earth, which is making constant angle, is a rhumb line, and a navigator prefers to sail on a rhumb line. Now, if I divide this distance between A and B into large number of small equal parts, then the sum total of all these small parts is the total distance between A and B. If I drop a perpendicular or as I said, draw a parallel of latitude through all these points B, E, D, A, we know that the parallel is perpendicular to the meridian. So we have these small triangles which we can consider that they are lying flat on the surface of the earth and can be treated as plain triangles. In no way we are disregarding the fact that the earth is a sphere. But for short distances, short triangles, small triangles, we can consider them to be lying flat. Then all these arcs, and we know the arc of the meridian is D.LAT. So we have these arcs, what are there? AF, CG, they all are D.LATs. And if we add up all together, we get the total D.LAT between A and B. Similarly, we know that the arc of latitude is the departure. So if we are able to add up all these departures together, we get the total departure between A and B. And these all triangles, I'm just assuming that they're sufficiently small that they can be lying flat on the surface of the earth. As I said, we are not disregarding the fact that the earth is a sphere. Now, when we are assuming all these as small right angle triangles, so we can assume even this triangle BAA as a plain right angle triangle, and that is acceptable for short distance sailing, which is up to 600 nautical miles. Above 600 nautical miles, when we talk about the mean lat formula, that if the D-lats are too big or your latitudes are too high, then this assumption is not acceptable. So up to 600 miles, we can consider this plane triangle. It's a plane triangle, and we do not incur much error. So within the limits of 600 miles, which is even the limits of traverse tables, we can find out our course and distance using trigonometrical function, as this is a right angle triangle. So you can see I've used perpendicular by hypotenuse sine. So that is your departure by distance is sine cos. Similarly, D.LAT by distance is cos cos. Departure by D.LAT is tan cos. And the formula what we talked about as mid-lat sailing was departure by D long, cos mid latitude, which we had after talking about parallel sailings, we had modified it for sailing between two latitudes. We know that the true departure lies on the mid latitude, but up to 600 miles, as we said, we can always substitute this mid latitude by mean latitude without any appreciable error. As we said that the change from mean to mid latitude, we required some corrections. Nowadays we don't use it, so we can comfortably continue using the formula. Instead of mid latitude, we can use mean latitude. Now we had learned about that we measure our angles, degrees from north right round in three figure notations. And the second system by which we measure our angles is your quadrant system, in which it has been divided into 4 quadrants: northeast, southeast, southwest, and northwest. And here the measurements are always done either from north, south, towards east and west. It's never from east to north or west to south. It's always from north and south that we measure our angles here. Now, as I said, 60 degrees is called northeast because it's making an angle of 60 degrees from north. And similarly, 290 degrees is making 70 degrees angle from north towards west. So we call it northwest 70. As I said, we never use east and west except when we'll be talking about amplitude, which will be a later on thing. In that case, yes, we do measure the angle for amplitude alone from east and west. But that is going to be a topic which we'll discuss later. Quadrant form, I prefer quadrant form because you see, like if I just said a course of 040, it doesn't strike me. Whereas if I said north 40 degrees east, it strikes me a little bit. So when I said a coast is northeast, that means it should be lying in this quadrant. Now this, when you have it in quadrant form, it gives me an indication that my D.LAT should be north and D-long should be east. Because if I'm going like this, definitely my D.LAT and D-long would be east. Or if I said there was the D.LAT was south and D-long was west, D-long south, D-long west. So I couldn't be going in any other quadrant other than this quadrant. So the quadrant form helps us to be able to figure out what is a D.LAT, what is a D-long. And similarly, knowing my D.LAT and D-long, I can figure out in what quadrant I'm steering. So this, we have already talked about it, that D.LAT is the arc of the meridian. Meridians are running north and south. So the D.LAT has to be always measured along north and south. Similarly, we talked about departure is the arc of the latitudes. Latitude run east and west, so departure is always measured east and west. This I am repeating because this is very important for you to understand, because to solve your problems on sailing or day's work or other things, you should be very clear about it, which way you measure your D.LAT and which way you measure your departure. Now, if the course has been given to me in quadrant form, and we know that the measurements are only from north or south towards east or west, if the course was given to me as northeast, so it has to be in this quadrant, northeast. This course is indicating to me that my D.LAT should be north and my departure should be east. If I drop a parallel of latitude from here onto the meridian, that would make an angle of 90 degrees, because all your latitudes cut the meridian at 90 degrees. And now we have got a plane triangle, plane right angle triangle, which we can solve to get anything in this. As long as I know two things, I can find out rest of the parameters of the triangle. Now D.LAT, again repeating, is measured north and south. Departure is measured east and west. Course given in three-figure notation converted into quadrant form gives me an indication of my D.LAT and D-long or departure. So course, when I said north 55 degrees east, D.LAT has to be north, departure should be east, and this is my plane triangle to solve for. Similarly, if the course has been given to me at 047 in quadrant form, it is south 33 degrees east. My D.LAT south, my departure east, and as I said, course always measured from south towards east, course Similarly here, course 235, quadrant form south 55 west. My D.LAT should be south, and my departure should be west. And course measured from south towards west, and we have this triangle to solve for. Similarly, if course is northwest, D.LAT north, departure west. And course always measured from north towards west. And this triangle should be very clear in your mind so that you do not make any mistakes when you have got to name your D.LAT, D-long or course when we'll be solving problems on parallel plane sailing or base work. Likewise, if I know D.LAT and D-long, I can get an indication of the course. If my D.LAT is north, my departure is east or D-long is east. If my D.LAT is north, D-long is east, so my course has to be in this quadrant, right? It can't be in any other quadrant. Because if I go here, my D.LAT is south. If I go here north and I'm heading, my D-long is west, so I'll be in this quadrant. So even your knowing your D.LAT and D-long, you can get an indication of what your course is. Similarly, when I said D.LAT south, D-long west, I should be in this quadrant. Now let's take an example of course 28 degrees, which is north 28 degrees east, and distance is 78. So course in northeast quadrant, angle with the north, D.LAT is north, and departure should be or D-long should be east. And this is a right angle triangle. Distance given to me is 72. Now I know two things. Using this trigonometrical functions, I can find out other things which I have to calculate. So using trigonometrical function, I found out my departure to be 33.8. Similarly, I found out my D.LAT as 63.6 for the course of 0 to 8 degrees, which is north 28 degrees east. So this is my D.LAT and departure for course 0 to 8 and distance of 72 miles. Now, let us just consider a complementary angle of 28. Complementary angle, that's two angles plus should be 90 degrees. So complementary to 28 is 62. Same distance 72. What was here? And let's try to figure out calculating our D.LAT and departure. Now here I have got the departure as 63.6 and D.LAT as 33.8. If you look at these two courses here, which are complementary, you can see that the D.LAT here, 63.6, has become the departure here. And similarly, the departure here has become the D.LAT here, the value wise. Now, that is basically because you look at this angle of 28 degrees, this has become the perpendicular and this is the base. So, in one case, what was the base? It has become the perpendicular. So, you will definitely get your answers opposite. If you go by this formula here, this is my base, this is my departure, this is my D.LAT. So, I'll get a different answer, whereas here, this was my perpendicular, this was my base. So, I get my opposite answers there. And this is relevant when we will be talking about and looking at it as for the traverse tables. Now, you can see here, now my perpendicular has become the departure here, which is lesser value than the value here, and this is my D.LAT, which was the D.LAT here. So this we'll just take it out when we start talking about reverse tables here. Now, knowing your D.LAT and departure, I can again find out my course also. If I know my D.LAT and departure, I can find out my course. One thing, if you notice here, tan is perpendicular to the base, which is departure by D.LAT, and tan 0 is 0. Now 0 divided by some value is only 0, isn't it? So for course of 0 degrees, the departure has to be 0. Rest of it is got to be D.LAT. So if you see here, if you're going on this course here, 0, 0, 0 or 180, so whatever distance a ship is traveling, that's only D.LAT. There is no departure. And once you talk about angle 45 degrees, tan of 45 degrees is 1. If you look at the formula here, departure by D.LAT is equal to 1. So that means they both will become equal. So at angle 45, departure and D.LAT is the same. 1. Same. Equal. And from 45 onwards, the value of tan increases from 1 to infinity. Now, that is possible that your denominator keeps on reducing and your numerator is increasing. So as you progress from 0 degrees towards 45, your D.LAT keeps on reducing and your departure keeps on increasing. And once you come to 45 degrees, then your departure keeps on reducing and your D.LAT keeps on D.LAT departure keeps on increasing and your departure D.LAT keeps on reducing. This is how we will notice it when we see the traverse tables here. So on the course of 0 degrees, your distance is your D.LAT and there will be no departure. On the course of 090, there will be only departure, no D.LAT. Traverse tables, they make our life easy because we don't have to use our trigonometrical functions. Of course, nowadays people are more comfortable using calculators. But these are easier for us to be able to convert our knowing the course and distance. We can always find out a D.LAT and departure by just looking at the tables here. The tables look something like this. And this is the top half top of the table, 28 degrees. And this we have got distance, D.LAT and departure. This part of it I am not discussing just now. I'll be talking to you a bit later. Now here we are just talking about converting from course and distance to D.LAT and departure. So what you have on top, 28 degrees, that's your course, and whatever distance is given to you here, you can always get your D.LAT and departure. This is the bottom end of the same page. You can see 60 to 28. These two are complementary angles which we had talked about. And you can see here that this is a continuation of the page. I was restricted because of the space on the slide. That's 60 degrees, 60 minutes here, distance 60 miles. Continues here, goes down to 120, 120 is the same values here, 240, 240, 300. The next page of this continues up to 600, which is the limit of traverse tables, what I told you earlier. Now here, if you look at it, the tables are on the top. We have the tables from 0 to 45 and the bottom part is from 45 to 90. That is the sum total of both from top and the bottom is 90 degrees. So you have 45 degrees from 0 to 45 on top and 45 to 90 at the bottom. So any angle what you see on top, the complementary angle would be at the bottom. So you don't have to search around where the complementary angle is. Sum total of top and bottom is always 90. So if you have got angle 30, below that should be 60. And if you notice here, all the possible angles, all the possible courses which are possible with angle of 28 degrees are given here. Northeast, southeast, southwest, northwest. Similarly, all the angles possible for 62 are given here. Northeast, southeast, southwest, northwest. So all possible angles in all the four quadrants are given on the tables, so you don't have to bother about it. And as we were discussing about it, you see, we saw that the D.LAT of 1 became the departure. So you can see here, this is the D.LAT when you're looking from top, and if you're looking from the bottom, this is your D.LAT. So this is where we just discussed in the last few minutes how the values remain the same, but the D.LAT becomes the departure, and the departure becomes the D.LAT. The D.LAT here is the D.LAT here, which is under departure. Now, this is the end of the table, which we have talked about is the limit of plain sailing 600 miles. So the tables start from distance of 0 up to 600 miles. So plain sailing ends at 600 miles. After 600 miles, we do not talk about plain sailing. Then we get down to Mercurius sailing. I'll continue with use of traverse tables next. Till then, thank you very much.